Hello dear friends, welcome back to MACSGATE. Now under probability and statistics, we are talking about random variables. In this part 2, we talk about mathematical expectation or expected value of a random variable. So this particular concept helps us in finding mean and variance of the distribution. Obviously the random variable will give you the probability distribution, and for that particular distribution we want to know the statistical measures, and we are mainly interested in the mean and variance, and for finding mean and variance we are going to use what is known as the mathematical expectation. So what I do is I start with an example where I try to give you the motivation for this mathematical expectation definition. Then we try to use this mathematical expectation definition for defining the mean and variance of the distribution. Let it be discrete probability distribution or continuous probability distribution. Okay, so let us start with the following example. Suppose in a class there are 3 students of age 20. So here we are having age of the student 20. How many students? Here number of students. We are having 3 students and 2 students of age 21. And 4 students of age 22 and 1 student of age 23. Now the question is, what is average age of the student? What is average age of the student? See my dear friends, whenever you are having the frequency associated with the value, how to find the average value my dear friends? X into frequency of X divided by sum of the frequencies. Okay, so using this we can find the mean or average. So what is it, sir? X into X means here age, and here frequency is how many students are having that particular age. Okay, so we are finding average age of the student. So actually it is like 20 age is for 3 students, 21 age is for 2 students, 22 age is for 4 students, and 23 age for 1 student. You can just add them and divided by how many? Okay, sorry, here I written reverse. 23 and 1 student. Is that clear? So if you add them divided by 10, you are going to get the answer, or we can use this frequency formula. What is it? 20 into 3, that is 60. 21 into 2, which is 42. 22 into 4, that is 88, plus 23, divided by sum of the frequencies, 3 plus 2 plus 4 plus 1, which is 10. So I think it is 213, please verify, divided by 10, which gives you the answer 21.3. So the average age of the student is 21.3 here. Okay, now if you observe this particular average age formula in terms of the random variable and its probability, so here the age of the variable, let us call X as the age of the student. Now what are the possible ages we are having? 20, 21, 22, 23. Now Px means probability that age of the student is 20. So out of 10 students, how many students are having age 20, sir? 3 students. So it is 3 by 10. How many students are having age 21? 2 by 10. How many students are having age 22? 4 by 10. How many students are having age 23? 1 by 10. See, actually when you are writing this particular formula, you can also write it like this. How you get this particular idea, my dear friends? When you written this, this can also be written like 20 into 3 by 10, 21 into 2 by 10, 22 into 4 by 10, 23 into 1 by 10. See, this is exactly what we are doing. So where 3 by 10 correspond to the probability that age of the student is 20. 2 by 10 is probability that age of the student is 21. This is probability that age of student is 22 and probability that age of student is 23. So you can write this average age, that is the average value which you found, can also be written in terms of this random variable and its probability. So how can you write it, sir? X into Px. Is it not like X into Px? You are multiplying and adding them. You are multiplying these two fellows and adding with the next x into px value, that is sum of x into px values. So this is the idea for defining your expected value, and this is what we call it as expected value of this particular random variable. Expected value of this particular random variable. Hope you understand. So this is the idea for defining expected value of a random variable, my dear friends. So it is actually the weighted average we are writing in a different manner. See here, even though you written average here, because we are having weights correspond to each value, so we actually call it as weighted average. So the expected value formula which you are actually writing is actually correspond to the weighted average formula. Okay, we can take one more example. A paid coin is tossed 3 times, expected number of heads. Okay, so coin is tossed 3 times. So what are the possible heads, my different number of heads? The number of heads possible are either you can get 0 heads, or you can get 1 head, or you can get 2 heads, or you can get 3 heads. Okay, now in number of cases you are going to get this many heads. So when you toss 3 coins, total 8 possibilities are. In that 8 possibilities, how many cases you are going to get 0 heads? How many cases you are going to get 0 heads? Head, head, head. Tail, tail, tail. That is one case. How many cases you are going to get 1 head, sir? Head, tail, 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 head, it. Okay, I can just write down. Let me write down all the 8 cases. HT, 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 HH, PT, HH, PT, 4 H's and 4 T's. So this is the case of 0 heads. That is one case. 1 head means how many cases? 1 head here, 1 head here, and 1 head here. 3 cases. 2 heads, how many cases? 1, 2, and 1 heads are this one, and one more fellow, which this one. It is 2 heads case. Am I clear? This is 2 heads case. Anyhow, 3 chances where you are going to get 2 heads. How many cases where you can get all the 3 heads? 1 case. Now here I want to know the expected number of heads, or you can say average number of heads. Average number of heads. So here, because each number is having some frequency associated with it, it is not a regular average, it is called weighted average. So this is actually the weighted average. The weighted average. So what is it, sir? 0 into 1. 1 repeated 3 times, 2 repeated 3 times, 3 repeated 1 times. Total is how much? Total cases 1 plus 3 plus 3 plus 1, that is 8 cases. And if write the same thing, like 0 into 1 by 8, 1 into 3 by 8, 2 into 3 by 8, 3 into 1 by 8. So the same thing can be expressed as sigma x into px, where x denotes the random variable, which is number of heads, which takes the values 0, 1, 2, 3, and this px denotes probability that the random variable get that many number of heads. So here, what is probability of 0 heads? 1 out of 8 cases. Probability of 1 heads? 3 out of 8 cases. Probability of 2 heads? 3 out of 8 cases. Probability of 3 heads? 1 out of 8 cases. And this is what we call it as the probability distribution, and this is your average or expected value of x. This is what we call it as expected value of x. So this is how we get the definition for expected value of a random variable, my dear friends. Am I clear? You can take one more example. Suppose we roll a die n times, that is, a dice is rolled n times. And say dice n times. What is the average of n numbers that appears on the top? What is the average of n numbers that appears on the top? So when you roll dice n times, what are the outcomes possible? The outcomes possible are 1, 2, 3, 4, 5, 6. Now, number of times you get that particular outcome, because totally you roll the dice n times. Out of that n times, one might be appearing n1 times, 2 might be appearing n2 times. That is outcome 2 appears n2 times, outcome 3 appears n3 times, and outcome 4 appears n4 times, 5 appears n5 times, and 6 appears n6 times. Where this n1 plus n2 plus n3 plus n4 plus n5 plus n6 is how much, sir? The total number of times you roll the dice. Now I want to know the average of the n numbers. What is the average of n numbers? So it is like, 1 appeared n1 times, so 1 into n1. 2 appeared n2 times, 2 into n2. 3 appeared n3 times, 3 into n3. 4 appeared n4 times, 4 into n4. 5 appeared n5 times, 5 into n5. 6 appeared n6 times, 6 into n6. Divided by sum of the frequencies, because n1 plus n2 plus n3 plus n4 plus n5 plus n6. But what is sum of the frequencies, sir? Sum of the frequencies n. So you can write it as 1 into n1 by, what is this? This is n, n1 by n. 2 into n2 by n. 3 into n3 by n. 4 into n4 by n. 5 into n5 by n. And 6 into n6 by n. And this one we can write it as, sigma x into probability of x. That is, when the dice is rolled, the outcomes are 1, 2, 3, 4, 5, 6. Probability of getting 1, n1 times out of n times. Probability of getting 2, n2 times out of n times. 3 appears n3 times out of n times. 4 appear n4 times out of n times. 5 appears n5 times out of n times. 6 appears n6 times out of n. And this gives you the average of n numbers, or weighted average you can call it. See, what do you mean by weighted average, sir? If each value is repeated, instead of getting average, we get weighted average. And that weighted average is what we call it as the expected value of this particular random variable. So with this motivation, let us define, of course, this one you can just ignore. We define expected value of the random variable. So how you define expected value of a random variable, sir? Okay, we can define expected value of random variable as sigma x into px, where x is the value of the random variable, px is probability of random variable taking that particular value. Now you can generalize this to a continuous distribution. It is for discrete probability distribution. The same idea we can generalize it for continuous probability distribution as expected value of a continuous random variable x is given by, so in a continuous case, summation is replaced with integration x into fx dx. Here x varies over all the values of the random variable, and here, because here x varies in the range of that particular domain. X takes all the possible values in the given domain. So generally we take it as minus infinity to infinity in general. Maybe in your particular problem, that particular domain may be from 0 to 1 or 0 to infinity. Accordingly you can change. In the remaining cases, probability will be obviously 0, so that part will be anyhow becomes 0. So this is how we define the expected value. Okay, so let us see the definition. Expected value of a random variable x denoted by e of x, or we call it as mathematical expectation of a random variable, and it is defined as, this is the definition, which is sigma x into px when x is discrete random variable, and this px is a probability mass function, and it is integral minus infinity to infinity x into fx dx when x is a continuous random variable. Here fx is a pdf, probability density function. Is the idea clear, sir? Now we can also have the definition for expected value of x square. Now you may have doubt, like when you get that kind of stories where we need to find expected value of x square. Suppose, okay, you and your friend are playing a game, okay, and suppose your friend said, that is, the game is you need to roll a dice. So your friend says whatever number you roll, square of that amount you will get it. Suppose if you roll 1, square of that 1 rupee you are going to get. If you roll 2, square of that number you are going to get, that is you are going to get 4 rupees. If you roll 3, you get 9 rupees. Okay. Now, what is the expected value of amount you are going to get? So here I am not going to ask you what is the expected value or average of the outcome. Here I am asking what is the average of amount you are going to get it. Okay. So actually X is the outcome on the die, whereas X square is amount you are going to get it. Amount per outcome. So it's like, if the outcome may be 1, 2, 3, 4, 5, 6, what is the amount you are going to get? This X square denotes the amount you are going to get. That is 1, 4, 9, 16, 25, 36. So here I am finding average amount. I am interested in average amount, not average outcome. So what I am going to find, sir? I am going to find expected value of X square, because I want expected value of amount, that is expected value of X square. In place of X, X square comes and the definition is exactly same. Only difference is in place of X, you are going to keep X square. That's it. So what is expected value of X square, sir? Sigma X square into Px when X is discrete random variable, where Px is probability mass function, and integral minus infinity to infinity X square fx dx when X is continuous random variable. Here Fx is the PDF. Suppose your friend said you are going to get cube of the outcome. You are going to get cube of the outcome. In that case, what happens? You are finding expected value of x cube. So similarly, you can find expected value of x square, expected value of x cube, expected value of any power also you can find. Okay. So you can also define in the similar manner what is expected value of x power r. Just in place of x square, you will have expected value of x power r. That is sigma x power r into px. In continuous case, integral x power r into fx dx. And this expected value of x power r is given a special name. It is called rth moment. What is it called? We call it as rth moment. So here, this is first moment, and expected value of x square mathematically is second moment. See, actually these higher order moments are useful in finding the statistical measure like, skewness, kurtosis, etc. We are not getting into that. So we are interested only in the mean and variance. For mean and variance, first and second moments are enough. That is expected value of x and expected value of x square are sufficient. So we are stopping there. But this expected value of x power r, that is rth moment or higher order moments, that is expected value of x cube, expected value of x power 4 and so on, they are called higher order moments, are useful for finding higher order statistical measures. That is the idea. Is the idea clear, sir? Like that. You can define them also. Now look at this example. Suppose same example you take, you roll a dice, the outcome may be 1, 2, 3, 4, 5, 6. And your friend said the amount you are going to get is defined by this function, that is 2x plus 3. So if you get 1, you get 2 into 1 plus 3, 5 rupees you are going to get. If you get 2, 2 into 2, 4 plus 3, 7 rupees you are going to get. So here the amount is defined by gx. It's not just x square, the amount is defined by gx. So it is 2x plus 3, 2 into 1 plus 3, 5, 2 2s 4 plus 3, 7, 2 3 6 plus 3, 9, 2 4s 8 plus 3, 11, 2 5s 10 plus 3, 13, and 2 6s 12 plus 3, 15. Now I can ask you what is the average amount you are going to get. So you are finding what's the expected value of gx. Story is exactly same. Instead of expected value of x, you get expected value of gx, that is x is replaced with gx. So we can also define expected value of any function, my dear friends. Am I clear? Expected value of any function. Up to linear function, this is a very straightforward story, my dear friends. So what is the answer? Expected value of gx is given by sigma gx into px when x is discrete random variable, where px is probability mass function, and integral infinity to minus infinity gx fx dx when x is a continuous random variable and fx is a PDF. So we can also define expected value of function also. This type of questions are very famous in GATE examination. Sometimes they regularly ask this type of question. Okay. We can easily see in gate examination around 4 to 5 questions based on expected value of gx also. Okay, and there are very important results based on this particular expected value, sir. What is expected value of constant? Expected value of constant is constant only. For example, you know what is expected value of x? Expected value of x is sigma x into px. So if it is expected value of constant, it is sigma c into px. C is a constant, you can take it out, it is sigma px. But you all know sigma px is 1, so you get c into 1, which is nothing but c. You can easily prove these results, my dear friends. Similarly, expected value of ax. A can be taken out. So what happens? A into sigma x into px, which is nothing but expected value of x only. And this can be generalized for any linear equation. Expected value of ax plus b. Actually, expected value of ax plus b can be written as, you know, expected value of ax plus expected value of b, and this is nothing but a into expected value of x, and expected value of constant is simply constant. So that is the important result. And it is when x and y are any two random variables. Suppose you are talking about sum of random variables. When you are talking about sum of random variable, expected value of x plus y or expected value of x minus y is defined as expected value of x plus expected value of y when there is a plus sign in between. If it is minus, then it is expected value of x minus expected value of y. It is also one of the important results. Got it? Now let us see how we can define the mean and variance of a random variable. Okay. See, mean of a random variable means what, sir? It is, you know, average. Average means expected value of the random variable. So mean is simply defined as expected value of the random variable. Okay. Now what is the variance? See, when we are studying statistics, I told you what is variance. How variance is defined, sir? The variance is defined as average of squared deviations from mean. So average. So average is obtained using expected value. Squared deviation from the mean. So from every value you are finding squared deviation. Squared deviation. Deviation from means are squared. So here you are defining the variance as expected value of x minus mu whole square. See, actually this expected value of x minus mu whole square, you can expand it. It can be written as, you know, a minus b whole square formula, a square minus 2ab or 2ba, you can write, plus b square. And whenever it is expected value of any linear or polynomial equation, you can separate them, sir. Whenever it is plus terms, you can happily separate them. So you can write it like, you know, you can consider this as expected value of x plus y or expected value of x square plus y square. You can separate expected value of x square, expected value of y square. Even if you are having any polynomial equation, you can just separate expected value, or you can apply that expected value to each of the terms. That is expected value of x square. 2 mu is constant, so it is into expected value of x square, and it is expected value of mu square. So this is nothing but expected value of x square minus 2 mu. The expected value of x means mean. We denote it by mu. So it is 2 mu into mu, that is 2 mu square, and expected value of constant is constant, that is mu square here. So it is expected value of x square minus 2 mu square plus mu square is nothing but minus mu square. So this is how we find variance of x. It is a simplified version. See, it is a lengthy version, means you are doing some redundant work. So when you simplify, we are doing less work here. So obviously this is a simple thing. Hi sir, thank you Mahi Gupta. Thank you very much. Welcome to the class. Hope you understand expected value of x square minus mu square. Is it clear? Actually, you can write it as expected value of x square minus mu means what? Expected value of x whole square. But this confuses a lot, sir. Sometimes people cancel this and they put 0 also. There is a difference between, please note. So here let me write here in cell, note expected value of x square is not same as expected value of x whole square. Please be careful. It is a mean, whereas it is expected value of x square. Please be careful. Okay, please be careful with this. Okay, because of that I generally don't write like this. I generally write the notation for expected value of x, that is mu, so that you will not have confusion. Please be careful. Now similarly we can also have, okay, sorry, where is variance? So this is the variance. Okay, so we define variance here. Now there are some results for variance also. The first one is variance of a constant. Okay, if you simply substitute, variance of constant means what, sir? Expected value of constant square minus c square, and expected value of constant square is c square minus c square is 0. Because of that you get it. And what about variance of ax, sir? See, when you take variance of ax, it is nothing but expected value of ax whole square, that is a square x square minus it is expected value of ax, that is mean of ax. Mean of ax is nothing but a into mu whole square, that is a square mu square. Oh, I did some mistake. 1 second. What is this? Expected value of this square minus what is it? Mean of ax, that is expected value of ax whole square. And here if you observe, this is a square into expected value of x square, whereas this is nothing but, there's something gone wrong. Yeah, this is nothing but a square into expected value of, or you can simply write like this. Now why you are unnecessarily wasting energy? You can simply write it as expected value of ax whole square, na? That is nothing but a square into mu square. So it is a square into mu square. So it is a square into expected value of x square, whereas this is a square into mu square. So taking a square common, you get expected value of x square minus mu square, that is nothing but variance of x. So that is the formula. So variance of ax is nothing but a square into variance of x. Got it? Next one, you can combine these two fellows. Variance of ax plus b will be a square into variance of x, because variance of constant is 0. But here I already told you, please be careful with this. Expected value of x square is not equal to expected value of x whole square. They are two different things. Please be careful. Yeah. So now let us take up some problems. See, the idea here is we are having distributions. Whenever you are having data or distributions, we need the statistical measures, because statistical measures characterize the data ya to distribution. Whenever you are having data or distribution, the statistical measures characterize them, means gives the properties to those distributions. Okay, so here we are having discrete probability distributions and continuous probability distributions defined by the random variable. Once you are having distributions, we can find the mean and variance of those distributions. And how to find mean, sir? Mean is nothing but expected value of x. How to find variance, sir? Variance is nothing but expected value of x square minus mu square. That is the idea, nothing more than that. Now let us see the following problem. In the following table, x is a discrete random variable and px is a probability mass function. You need to find the standard deviation of x. Of course, you might be asking like, sir, you not given what is standard deviation? Standard deviation is simply positive square root of variance. Once you have the variance, positive square root of that is standard deviation, nothing more than that. Now, whenever you want to find standard deviation, we need to find variance. Okay, so first let me tell you the formulas. The mean is nothing but expected value of x, and the variance is nothing but expected value of x square minus mu square. So if you want to find variance, first of all you need mean. Okay, now what is mean? Which is expected value of x of a discrete probability distribution, that is nothing but sigma x into px. So what is it? 1 into 0.3 plus 2 into 0.6 plus 3 into 0.1, which is nothing but 0.3 plus 1.2 plus 0.3. which is nothing but 1.8. So the mean here is 1.8. Then you need to find variance before going for standard deviation. But for variance, first of all, you need to find expected value of x square. So what I am doing is I am finding expected value of x square, which is nothing but sigma x square into px. See here x is given, na? X square means what? X square means square of this, square of this, square of this. That is 1 square into 0.3, 2 square into 0.6, 3 square into 0.1. That is expected value of x square. 1 square into 0.3, 2 square into 0.6, 3 square into 0.1. So that is nothing but 0.3, 2.4, 0.9. That is nothing but 1.2, 3.6. So this is expected value of x square. See, the most common mistake which people do is they take it as variance. Please be careful, it is just expected value of x square, not variance. Variance is expected value of x square minus mu square. That is 3.6, which is expected value of x square minus mu square. What is mu square, sir? 1.8 whole square. So use your calculator to find this answer. Okay, I think I already written this value. You should get around 0.36, my dear friends. Please verify that. Okay, once you have variance, you can find standard deviation, which is positive square root of variance, which is under root 0.36. So which is 0.6. So standard deviation is 0.6. See, why standard deviation, sir? Variance units will be square of the units of the problem. Suppose your problem is in terms of some meters, variance will be in terms of meter square. Because of that, they find standard deviation. Okay, because variance gives you the spread of the data, but the units will be in terms of meter square. Okay, suppose your data is in meter, it is in meter square. Because of that, we find standard deviation, because it is square root of meter square means you are going to get meter. That is, in the same units of your data, you are going to get the result. The spread you can define in the same units of your data. For that purpose, standard deviation is very better measure than variance. That is the idea. Of course, obviously, variance also tells you about the spread of the data, but the units are different. Please note that. Next one. A 6-phase fair dice is rolled a large number of times. Okay. The mean value of the outcome is. This is a very interesting problem, and this is called the trap in this problem. So it says it is rolled a large number of times. So large means what? 2 times, 3 times, 30 times, 300 times, 30,000 times. We do not know. But if you observe the question, he is asking what is the mean value of outcomes. Suppose you roll the dice 1 time. What are the possible outcomes? 1, 2, 3, 4, 5, 6 only. You roll the dice 10 times. What are the possible outcomes? Outcomes are 1, 2, 3, 4, 5, 6. But when you roll 10 times, 1 may occur 4 times, 2 may occur 3 times, 4 may occur 1 time. Like that it may happen. So that the sum of that frequencies must be equal to 10. Suppose if you roll 10,000 times, some of the frequencies will be 10,000, but the outcomes are not going to change. Here we are finding mean value of the outcomes. So what are the outcomes? What are the outcomes, sir? 1, 2, 3, 4, 5 and 6. Okay, so we need to find the mean value of the outcomes, and this is the random variable. So I define my random variable as outcome on the die. What is my random variable, sir? I define my random variable as outcome on dice. So that is 1, 2, 3, 4, 5, 6. So this is my random variable x. So x takes values 1, 2, 3, 4, 5, 6. And you just need to find probability of x. And because it is a fair dice, all outcomes are equally likely. Probability of 1 is 1 by 6, 2 is 1 by 6, 3 is 1 by 6, 4 is 1 by 6, 5 is 1 by 6, 6 is 1 by 6. Now you need to find expected value of outcome on the dice. Mean means expected value only. So what is mean value, sir? That is nothing but expected value of x, which is nothing but sigma x into px. So 1 into 1 by 6, 2 into 1 by 6, 3 into 1 by 6, 4 into 1 by 6, 5 into 1 by 6, 6 into 1 by 6. But 1 by 6 is common, so I just take it common. So 1 by 6 into 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is nothing but 6 into 6 plus 1 by 2. You know, sum of first 6 natural numbers is 6 into 6 plus 1 by 2. 6 cancel, 6 plus 1, 7 by 2, which is 3.5. That is answer. Is the idea clear? Okay. Next question. If the probability density function of a random variable, here it is, you know, continuous probability distribution, because PDF is given. The probability density function of a random variable is given by this. This is the probability density function. He is asking you to find expected value of x. Okay. So what is expected value of x? Definition, my dear friends. It is, for continuous probability distribution, it is minus infinity to infinity x into fx dx. And your function is just defined from 0 to 1, elsewhere it is 0, so we can ignore elsewhere. So 0 to 1, x into, what is fx in 0 to 1, sir? 2x. So taking 2 common, integral x square dx. Limits are from 0 to 1. So x square integral is nothing but x cube by 3, limits are going from 0 to 1. Lower limit is anyhow 0, it is 1 by 3. 1 cube means 1, 1 by 3. So 2 by 3 is the expected value. So what is the expected value, my dear friends? The expected value is 2 by 3. So we call it as mean. Mean is 2 by 3. Clear? Then comes variance. But before variance, we need expected value of x square, because variance is defined in terms of expected value of x square minus mu square. So first let us find expected value of x square. So what is expected value of x square, sir? It is integral minus infinity to infinity x square into fx dx. So it is from 0 to 1, x square into, what is fx, sir? 2x dx. So 2 is constant, integral 0 to 1, x square into x is x cube dx. So that is 2 into x power 4 by 4, limits are from 0 to 1. So what is it? 1 by 4, because 1 power 4 is 1 only, 1 by 4 minus 0. So what is it? 2 into 1 by 4, which is 1 by 2. So this is your expected value of x square. So once you have expected value of x square, you can find variance of x, which is expected value of x square minus mean square. Expected value of x square is 1 by 2 and mean is 2 by 3. So it is 1 by 2, mean is 2 by 3, so 2 by 3 whole square. So when you simplify, 1 by 2, 4 by 9, LCM is 18, 9 minus 4 to 8, which is 1 by 18. So what is variance of x, my dear friends? Which is 1 by 18. If you want, what is standard deviation? Which is square root of 1 by 18. Is the idea clear? Next question. If x and y are random variables such that expected value of 2x plus y is 0 and expected value of x plus 2y is 33, then what is the expected value of x plus expected value of y? So here you can just see this. What is given? Expected value of 2x plus y is given as 0 and expected value of x plus 2y is given as 33. And you all know expected value of, this is the result, sorry. Sorry for that. We all know expected value of ax plus b is nothing but a into expected value of x plus b. So let us use this. So it is expected value of ax plus b is nothing but what, sir? 2 into expected value of x plus y is equal to 0. And what about this? This is expected value of x plus 2 into expected value of y, which is 33. See, this is what you get it from this, and this is what you get it from this. Now what I do, I just add them. If you add 2 times expected value of x plus expected value of x, which is 3 times expected value of x, and 1 plus 2, 3 times expected value of y, and 0 plus 33 is 33. Now here I can take 3 common, so that I get expected value of x plus expected value of y, which is 33. So what is expected value of x plus expected value of y, my dear friends? 33 by 3, which is nothing but 11. So what is the answer for this problem? Which is 11. Is the idea clear? Hope you understand. Very good. This is also a very interesting problem, very recent GATE question, a simple one. 2 continuous random variables x and y are related as y is equal to 2x plus 3. He is asking how variance of x and variance of y. See, this is the notation we use for variance. Okay. So this sigma x square is nothing but variance of x. This is the notation. Sigma y square is the notation for variance of y. Hope you understand. Okay. Now this is the result given, y is equal to 2x plus 3. And you can apply variance on both sides. So variance of y will be variance of 2x plus 3. So variance of y means sigma y square. Now what is variance of ax plus b? Variance of ax plus b is nothing but a square into variance of x. So this is 2 square into variance of x. And that is nothing but sigma y square is nothing but 4 times variance of x. Variance of x means sigma x square. Direct problem. Got it? So what is the answer? B is the answer. If x is a random variable with expected value of 5 and variance 1. So we are having a random variable x with expected value 5. So what is expected value of x? That is 5, and variance of x is 1. Then what is expected value of x square? So question is what? What is expected value of x square? My dear friends, you all know what is variance. This is a very regular question in GATE, sir, this type of relation. Variance of x is nothing but expected value of x square minus mean square. So variance of x is given. We need to find expected value of x square. Mean, this is nothing but mean. Mean square means 5 square. So what is expected value of x square, sir? 1 plus 5 square. That is nothing but 1 plus 25, yani 26. Straightforward question. Now I told you, this is also GATE question, sir. What is expected value of e power x? Gx. I told you na expected value of gx is nothing but, if it is continuous distribution, integral minus infinity to infinity gx into pdf. What is pdf? fx dx. That's it. Nothing more than that. So what is expected value of e power x, my dear friends? Integral minus infinity to infinity e power x into fx dx. But what is fx? Fx is only defined from 0 to 1. So it is nothing but 0 to 1 e power x. From 0 to 1 fx is nothing but 1 dx. So it is e power x into 1 is e power x. Integral of e power x is e power x. Limits are from 0 to 1. E power 1 minus e power 0 is 1. E minus 1 is the answer. Okay. So it is 2.71 something. So up to 2 decimals means you can write 2.71 means 2.71 minus 1 means 1.71 approximately. Is that clear? Or 1.72 approximately you can write. Clear? Very interesting question. Very beautiful question. Each of 9 words in the sequence, the quick brown fox jumps over the lazy dogs are written on a separate piece of paper. So each word in the sentence, the quick brown fox jumps over the lazy dog. So each word is written on a separate piece of paper. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces are there. These 9 pieces of paper are kept in a box. So all these papers are put in this particular box. One piece is drawn at random. The question is the expected length of the word drawn. What is the expected length of the word drawn? See, when you ask this particular question, immediately from this you understand expected value of a random variable. So first question is, what is random variable? Expected length of the word. So random variable is length of the word. So random variable is length of the word. And here if you observe, what are the words, word lengths we are having? The, which is word of length 3, quick, word of length 5, brown, word of length 5, tree length, gems length 5, over 4, the 3, lazy 4, dog 3. So what are the possible lengths we are having in this set? 3, 4, 5 are the possible lengths. Now he is asking expected value of this random variable. So first you need to find probability. You need to find probability. See, total 9 are there. How many of length 3 are there? How many of length 3 are there? 1, 2, 3, 4 of length 3 are there. So 4 by 9. 4 favorable for length 3. How many length 4 are there? 1, 2. 2 out of 9. How many length 5 are there? 1, 2, 3. That's it. 3 only, no? 4 plus 2, 6, 6 plus 3, 9, right? 3 by 9. Now you just need to find expected length of the word. Means you just need to find expected value of x, which is nothing but sigma x into ex. 3 into 4 by 9, 4 into 2 by 9, 5 into 3 by 9. So 9 is common. 3 4s 12. 4 2s 8, 20, 35. So it is 35 by 9. So the answer is 35 by 9. Got it? For probability density function of a random variable x, fx is given, then what is mean of the random variable? That is, PDF is given, is asking mean of the random variable. Direct question, sir. Mean means what? Mean is nothing but expected value of x, which is nothing but integral minus infinity to infinity x into fx dx. So here the function is defined only from 0 to 2. So 0 to 2 x into what is fx? X by 4 into 4 minus x square dx. So this can be written as 0 to 2. It is x square by 4 into 4. 4 4 cancel. You get x square minus x power 4 by 4 dx. So when you integrate it, you get x cube by 3. Limits from 0 to 2. X power 5 by 5. 5 4s 20. Limits from 0 to 2. So it is 8 by 3 minus 0. That is 8 by 3 minus 0. And here it is 2 power 5, 32 by 20. 32 by 20 minus lower limit is 0. So here 4, not 4, 2 16s, 4 will go na, 4 8s, 4 5s. So here you are going to get 8 by 3 minus 8 by 5. So LCM is 15, 5 8s 40, 8 3s 24, 16 by 15 is the required answer. Okay. If it is in the decimal format, up to 2 decimals, you can write the answers. Next one. This is also a very interesting, important question. An exam paper has 50 MCQs of 1 mark each. So we are having 50 MCQs where each question worth 1 mark. And here each question is having 4 choices. Very good. Each incorrect answers gives you minus 0.25 marks. So there is a negative marking. Okay. So obviously here 1 mark each means this is for correct answer. This is for incorrect answer. So we are having marks for correct answer and marks for wrong answer. Wrong answer will give you minus 0.25. These are the marks. If the answer is correct, you get 1 mark. If the answer is wrong, you get negative mark, which is minus 0.25. Suppose 1000 students choose all their answers randomly with uniform probability. The sum total of their expected marks obtained by all students. See, here we need to find expected value for 1000 students. See, my dear friend, each student write 50 questions. Okay, then we have to generate it for 1000 students. First of all, this information is just given for one question. Here we are having information for one question. So find expected value for one question. Find expected value for one question where x is for one question. That is one student for one question, how many marks expected. If you multiply with 50, one student for 50 marks, you will get it. If you multiply with 1000, you get the expected value for 1000 students. So that is the story, my dear friends. See, once you get the expected value for one student, because all are uniformly distributed. So for every student, the story is same. So for one student, 1 mark, first find the expected value. Then you multiply by 50. So you get expected marks for one student, because one student write 50 questions. That you multiply by 1000, you are going to get expected marks for 1000 students. Okay. So x is marks for one student for one question. X is the random variable. Marks for one student for one question. So what are the expected, what are the possible marks, sir? Either he can get negative marking, which is minus 0.25, or he can get positive marks, 1 mark. See, here the MCQ is having 4 choices. We know 4 choices, 1 is correct, 3 are wrong choices. So this correct choice if he gives, he'll get full marks, that is 1 mark. Any one of the wrong choice if he select, he'll get negative marks. So probability of selecting negative mark or probability of getting negative mark is 3 favorable out of 4. Probability of getting correct answer is only 1 out of 4. Suppose he started guessing for everything. So this is the probability. So now from this probability distribution, you can find probability of x. That is probability of, not probability, sorry, we can find expected value of x. That is expected marks for one student for one question. Expected marks for one student for one question. So what is it? Sigma x into px, which is minus 0.25 into 3 by 4 plus 1 into 1 by 4. By 4 is common. So it is minus 0.75 plus 1, which is nothing but 0.25 by 4. Is that clear? That is for expected marks for one student for one question. This is expected value of x is 0.25 by 4. This is expected marks for one student. Expected marks for one student for 1 mark. Expected marks for one student for 1 mark. Now can you tell me what is expected marks for one student for 50 marks? For 50 marks. So for one question it is this much, for 50 questions it is this into 50. Now you can tell what is expected marks for 1000 students. So one student expected mark, you know, for 1000 you have to multiply by 1000. So simplify that to get the required answer. Simplify this to get the required answer. Please verify, sir. I remember this answer. Somewhere I written also 3125, I think. Please check this. Multiply this and get the answer. Is the idea clear? Next one. Consider the following probability mass function of a random variable x given like this. See, sometimes when you see like this, you may feel like it is a continuous distribution, but it is not. That he clearly says it is a mass function. We generally write px naught. To confuse you, given a different notation. But what he's saying, this random variable takes either 0 value or 1 value with the probabilities q and 1 q and 1 minus q respectively, and q value also given here. So x is a random variable which takes value either 0 or 1 with the probabilities. Of course, this probability is writing it as p of xq. You can write px, no problem, that is just a notation. So p x0, probability for x is equal to 0 is q. Q means what? 0.4. And x is equal to 1 is 1 minus q. 1 minus 0.4, that is 0.6. So this distribution he given indirectly, and he is asking what is variance. Same story, distribution is given, find mean, find variance. So first we need expected value of x, sigma x into px. So it is 0 into 0.4 plus 1 into 0.6, which is 0.6. Okay. Now once you got it, then you can find expected value of x square. What is expected value of x square, my dear friend? Sigma x square into px. So that is x square means 0 square 1 square. So it is 0 square into 0.4 plus 1 square into 0.6, which is nothing but 0 plus 0.6, which is 0.6. Now we need to find variance of x. So the variance of x is expected value of x square minus mu square. See, expected value of x square is 0.6, but mu is this one. Expected value of x is mu. So mu square means it is 0.6 whole square. See, most of the student in the examination given 0 answer for this. They got 0 or negative marks actually. Please be careful. So it is 0.6 minus 0.36. And that is 0.24. So you need to find variance, which is 0.24, my dear friend. Please understand that. Please be careful. Hope you understand. Yeah. So I think we conclude with the last question, a simple one. X be a continuous random variable denoting the temperature measured. Let it measure whatever it is, we don't care, sir. The range of temperature is 0 to 100 degrees Celsius. Let the probability density function is given from 0 to 100. What is the mean of x? Mean of x is nothing but what? Expected value of x. Continuous random variable, so integral minus infinity to plus infinity, but here it is given from 0 to 100. So 0 to 100 x into what is fx? 0.01 dx. That is 0.01 into integral of x is nothing but x square by 2. Limits are from 0 to 100. That is 0.01 into 100 square, which is nothing but 100 by 2 also there. Please don't forget. So which is nothing but 50. Okay. So that is the answer for this problem, my dear friends. So this is about expectation. So let me just briefly tell you what we done so far in random variable. So we are having a random experiment. For that we get a sample space. So random variable associate real numbers to outcomes of a random experiment. Okay. So that is what random variable will do. Now to the values of the random variable, we associate probabilities using probability functions. If it is a discrete random variable, we are having PMF. If it is a continuous random variable, we are having PDF. So here we are going to get XPX distribution. So here we are going to get discrete probability distribution. Generally the discrete distributions are in the tabular formats, X and PX. And when X is a continuous random variable, this Fx is a PDF. And this will give you continuous probability distribution. And generally they are in the form of graphs. So here this Fx function will be given. Okay, using this particular functions, we are actually going to find the statistical measures for these distributions. So once you are having distributions, we require statistical measures. See, for any data or distribution, we are going to find the statistical measures which characterize, which gives you the properties for that particular data or distribution. So for discrete or continuous distribution, we are mainly interested in two statistical measures. One is mean, the other one is variance. Okay, the mean is simply given by expected value of x. It is simply sigma x into px for discrete distribution, and the variance is given by expected value of x square minus mu square. And for continuous distribution also, the story is same, only difference is the expected value of x is in terms of integral minus infinity to infinity x into fx dx. Variance is also same formula, but here we are going to use the integration instead of summation. That is the story. Okay. So whenever they give you any distribution, they can ask you mean or variance or standard distribution or something related to that. You just need to use the formula, you are going to get the answer, my dear friends. So please remember this formulas for expected value of x, which is what? Sigma x into px for discrete case and integral minus infinity to infinity x into fx dx. You can also find expected value of x square, which is same as sigma expected value of x, only difference is in place of x you get x square, that's it. X square into px, and here integral x square into fx dx. Is that clear? So use that and get the answer. That's it, my dear friend. One of the easiest type of questions which you get in GATE examination are based on random variables and the statistical values or statistical measures for the random distributions, like finding mean and variance. Most easiest questions, my dear friends. And you know, most of the people, why they fail in answering these questions? They worry about unnecessary details. For example, here when they give you this question, they worry about, you know, what the temperature measured, how it is measured, and unnecessary nonsense. We are not worried about how the temperature is measured. You don't go and measure the temperature there, sir. That is given, we are using it. Please note one point, we are not deriving anything. We are just using the results which are already there. Okay, it is just a data. Am I clear? So that particular data, we are trying to know the properties of the data. So that particular data may be a data of a medical data, or it may be a psychological data, or it may be a data of an election, it may be data of something else, it does not matter. We are taking the data, we are trying to find the properties related to data. That's it. That is what we need to understand. Is that clear? That's it. If you go that way, this is the one of the easiest part in your GATE examination, my dear friends. Okay. And in this probability and statistics one, now we need to talk about some important discrete probability distributions and some important continuous probability distribution. Okay. So I'll stop it here. Maybe next time I come up with maybe this binomial Poisson distributions, which are discrete probability distributions. For continuous probability distribution, we are having uniform, exponential, and normal distribution. So I'll be doing these topics now and then, my dear friends, because with this knowledge we can move on to probability and statistics too. Okay. So whenever I take those topics, I'll be announcing that. Okay. And probability and statistics will continue, sir, because it's a very lengthy topic, because we are having for other branches, for all the branches, just 5 more distributions we have to discuss. For example, we need to discuss binomial, Poisson, exponential, uniform, and normal distributions. Whereas for data science and artificial intelligence, the story is just half done. We are having half probability left. Am I clear? Please note that. That's all for today. Thank you.